Dear 8th standard students, now we'll do lesson chemical reaction and oxides and their nature. We'll start with this one. See, oxides are important class of compounds. We know that two simple oxides, water and carbon dioxide, and both these plays important role in life processes. Carbon dioxide is used in photosynthesis, water is also used in photosynthesis, and water is used in the important for human beings and animals also. So they are playing important role in life processes. Now preparation of oxides by direct combination. Direct combination means directly will take the elements which are present in oxide. Like in water, which elements are present? Hydrogen and oxygen. So we treat hydrogen and oxygen directly. Hydrogen react with oxygen on ignition, on burning, and form water. All of you know. Same way, carbon on burning form carbon dioxide. Sulfur dioxide have two elements, sulfur and oxygen. So sulfur and oxygen on burning form sulfur dioxide. These are non-metal oxides. Now come to this one. Magnesium and calcium are metal. So magnesium on burning, on heating, react with oxygen and form magnesium oxide. This is metal oxide. Calcium on burning with oxygen form calcium oxide, that is also metal oxide. So non-metal oxides are also there, metal oxides are also there. By thermal decomposition, second method for the preparation of oxide is by thermal decomposition of some compounds. See, some compounds like hydroxide, carbonates, sulfates and nitrates, on heating they form their oxide, and oxides are bases. Zinc hydroxide and calcium hydroxide. All hydroxide if you see the activity series, from calcium to copper hydroxide, all hydroxide on heating decompose form their oxide. Zinc hydroxide will form zinc oxide, copper hydroxide will form copper oxide, and water in both the cases, right? And you note down the color. Copper hydroxide is bluish white or pale blue, hikka neela, and copper oxide is black in color, right? So these are bases. Carbonates, all carbonates except sodium potassium carbonate decompose from calcium carbonate to copper carbonate in the activity series. Just check the activity series which we have already done. From calcium carbonate to copper carbonate, any carbonate you take in between. How it behaves? On heating form oxide of the metal. Calcium carbonate will form calcium oxide and carbon dioxide. Zinc carbonate form zinc oxide and carbon dioxide. Lead carbonate will form lead oxide and carbon dioxide. Copper carbonate will form copper oxide and carbon dioxide. Calcium carbonate and calcium oxide both are white. Zinc carbonate is white, but zinc oxide is white when cold and yellow when hot. We'll discuss it afterwards also. Lead carbonate is white, but its oxide, lead oxide, is reddish brown when hot and yellow when cold. Copper carbonate is green in color, but its oxide, copper oxide, is black in color. Right? Same way, if you check ferrous sulfate, ferric sulfate, Fe2SO4 thrice, on heating it will form ferric oxide. Again, this is a base. Okay, and basic oxide, and base oxide means metal oxide is normally basic. Copper sulfate on heating form copper oxide and sulfur dioxide. So this is black, this is a base metal oxide. Okay, and copper sulfate beta having very weak bond, dot means weak bond with water, 5 water. This is blue in color. This is called also called blue vitriol. Punjabi ch kende enu neela thotha, right? But sodium, potassium and calcium sulfates, they do not decompose on heating. Nitrates, again from calcium nitrate to copper nitrate according to activity series. When they are heated, these nitrates are heated, they decompose forming their oxide. Calcium nitrate form calcium oxide. Lead nitrate will form lead oxide. And other two products are same in both. Nitrogen dioxide, oxygen, nitrogen dioxide and oxygen. Right? And but sodium and potassium nitrate on heating, they do not decompose like this. In fact, sodium and potassium nitrate, when they I'll write reaction here, you check. sodium nitrate, when it is heated, it will not form oxide, it forms sodium nitride. NaNO3, here NaNO2 plus oxygen. And same way potassium nitrate also, on heating form potassium nitride 2KNO2 plus oxygen. So their decomposition is different here. Here you see lead nitrate. When you see lead nitrate is heated, it forms lead oxide and nitrogen dioxide. This brownish gas, reddish brown gas which is coming out is nitrogen dioxide gas. Okay, reddish brown fumes are there. Classification of oxides. Beta, oxides are of 4 kinds. Neutral oxide, those oxide which are neither acidic nor basic. Acidic oxide, those oxide which are acidic. And some oxides are basic. Acidic oxides are normally non-metal oxides. Basic oxides, some oxides are basic. Metal oxides are normally basic oxide. Amphoteric oxides, some metal oxides behave like acid as well as base. Both, their behavior is both behaviors. They are amphoteric oxides. Neutral oxide, only 4 oxides, non-metal oxides are neutral. Water, carbon monoxide, nitrous oxide. This nitrous oxide is also called laughing gas. Laughing gas doesn't mean it is good, it's a poisonous gas only. If somebody inhales, that person cannot able to close the mouth. If somebody is having open mouth, what we can say? Laughing. So in that sense it is called laughing gas. Nitric oxide, NO. So 4 neutral oxides are there, and they do not react with acid or base, right? Normally they do not react. Acidic oxide. Non-metal oxides are generally acidic oxide, and these oxide, non-metal oxide, they dissolve in water and form acid. And that acid form, naturally acid can neutralize bases. We have already done neutralization reaction. So these acidic solutions, they neutralize basic solution to form salt and water. And next page you see here carbon dioxide dissolve in water to form carbonic acid. Sulfur dioxide dissolve in water to form sulfurous acid. Sulfur trioxide dissolve in water to form sulfuric acid. Nitrogen pentoxide dissolve in water to form nitric acid. Right? Then some wording is there. You see, a compound that is obtained by removing the elements of water from acid is called anhydride. See, I will show you here. This is carbonic acid. Carbonic acid. If I subtract water from it, means remove water from it. 2H, 2H, H2, H2 minus H2, 0. 1 carbon, here no carbon. So 1 carbon minus 0 carbon, 1 carbon. 3 oxygen minus 1 oxygen, 2 oxygen. So if I remove water from carbonic acid, what we get? Carbon dioxide. Same way, if from sulfurous acid I subtract water, then what I get? Sulfur dioxide. If from sulfuric acid H2SO4, if I subtract water, elements of water, what I get? SO3. Right? Same way, if from 2 nitric acid I subtract water, then what will get? N2O5. Okay, and these substances obtained when water is removed from acids, they are called anhydrides. What are they called? Anhydride. Carbon dioxide is anhydride of carbonic acid. Sulfur dioxide is anhydride of sulfurous acid. Sulfur trioxide is anhydride of sulfuric acid. Nitrogen pentoxide is anhydride of nitric acid. Right? So these are anhydrides. Clear? Now beta, next thing is a compound that is obtained by removing water of elements is called anhydride. I have already explained you what is anhydride. Or in other words, if in anhydride, if you add water, these are anhydride, if you add water to it, what you will get? Acid you will get. Anhydride dissolve in water to form acid. So carbon dioxide is anhydride of carbonic acid, sulfur dioxide is anhydride of sulfuric acid, sulfur trioxide is anhydride of sulfuric acid, nitrogen pentoxide is anhydride of nitric acid. Right? Acidic oxide turn moistened means water. Blue litmus paper red. You have to learn this. So you know acidic oxide actually carbon dioxide say first of all react with water of present in the moist blue litmus paper. Moist means water is there. Moist blue litmus paper that have water. So first of all this acidic oxide react with that water to form acid, carbonic acid, and that turns the blue litmus to red. You know acid turn blue litmus red. Right? This is what is told here. Now reaction with bases. Carbon dioxide is acidic oxide, sodium oxide is basic oxide, metal oxide. They react to form salt, sodium carbon, directly they react. Sulfur dioxide react with KOH. KOH is a base. This is basic oxide, this is basic hydroxide, and form salt and water. Maybe some student will say, sir, here water is found, why not here? But if you check here, there is no hydrogen on the left side, so no water. Here hydrogen is there in base, so water is also present here. And why sulfur dioxide forms sulfites? Because you know sulfur dioxide is a acid anhydride of sulfuric acid. So and sulfuric acid has a negative part SO3. So therefore salt of sulfur dioxide also will have negative part SO3, that is potassium sulfite only is formed. Okay, basic oxides. Metal oxides are generally basic in nature and they react with acid to form salt and water. Right? They react with acidic oxides also to form salts. See, sodium oxide is basic oxide, react with sulfuric acid to form salt and water. Base, acid and base react to form salt and water. Magnesium oxide is also basic oxide, react with acid HCl to form salt, magnesium chloride and water. Same way calcium oxide. Calcium oxide also react basic oxide, react with carbon dioxide. See, this is acidic oxide, not acid. This is acidic oxide, acid anhydride, but they react to form only salt. If it is acid here, say HCl, then salt and water. Right? But if it is only acid anhydride, then one product is formed, that is salt only. Basic oxide which are soluble at least to some extent in water, right? They moistened red litmus is turned blue by them. Right? Thus the freely soluble metal oxides like sodium oxide, this is highly soluble in water. Right? And calcium oxide is slightly soluble in water. Magnesium oxide is very slightly soluble in water. So they will turn moist litmus paper blue, red litmus paper, moistened red litmus paper to blue color. But copper oxide, you know, does not dissolve in moisture, does not dissolve in water. So copper oxide will not turn moistened red litmus paper blue. So first three are acidic oxide, but this is not acidic oxide. Do you understand? Right? This is not acidic oxide, although first three are basic oxides, not acidic oxide, basic oxide, but this one is not, you know, the color of moistened red litmus paper is not turned blue. It means copper oxide, although it is oxide, it is not showing basic behavior, but it doesn't mean it is not oxide, it is not base. It is base, although does not affect the red litmus paper. Right? Amphoteric oxides now. Amphoteric oxides is one which behave like base as well as acid. If see, I'll show you first of all. This is amphoteric oxide. When it react with acid, typical acid, then the behavior of zinc oxide is base. So acid and base, you know, react to form salt, zinc sulfate and water. When this same zinc oxide react with the base, earlier it react with acid, now it react with base. same zinc oxide react with base, then its behavior is like that of acid. Now here it behave like acid and here it behave like base to form salt, sodium zincate and water. Same way lead oxide, when lead oxide react with acid, the behavior of lead oxide is like that of base to form salt and water, lead nitrate and water. Same lead oxide when react with base, sodium hydroxide is a typical base, then the behavior of lead oxide is that of acid, so it forms sodium plumbite and water. Right, so now you come to this. Amphoteric oxide is one which behaves like a base in the presence of acid. Zinc oxide in the presence of acid behave like base. And like acid, same zinc oxide, it's amphoteric oxide, behave like acid in the presence of base. So those oxides are called amphoteric, and 3 examples are here. 2 are with the equations explained in your book and third one is aluminum oxide. Now activity, take about 3-5 gram of zinc carbonate and heat it strongly. You know, zinc carbonate on strong heating form zinc oxide and carbon dioxide. Right, so zinc oxide is formed and this zinc oxide form, carbon dioxide is a gas, it will escape. Zinc oxide is formed. This zinc oxide is when it is hot it is yellow, when you cool it down it becomes white, and that white zinc oxide you take, and that white zinc oxide if you again heat, again it will become yellow, again you cool, again it will become white. And we take that zinc oxide and we divide it into 2 parts. We take zinc oxide, little part in one test tube, little part in other test tube. In one test tube which contains zinc oxide, we add dilute sulfuric acid. And what we find, that zinc oxide dissolve in dilute sulfuric acid forming zinc sulfate. It dissolves quickly. And in another test tube, zinc oxide we have taken the second one also, and here we add dilute sodium hydroxide solution and we shake well, and what we find, here also zinc oxide dissolve in sodium hydroxide. So zinc oxide dissolve in sulfuric acid also means react with sulfuric acid, so it behave like base. Zinc oxide dissolve in sodium hydroxide also, this is a base. Okay, zinc oxide react with base also, sodium hydroxide, therefore zinc oxide behave like acid. So this activity proves this, and here they are showing in the form of diagrams. Another example is lead carbonate. Take 3-5 gram of lead carbonate and heat. I am showing reaction here. PbCO3 on heating form PbO plus carbon dioxide. So PbO is formed, residue is formed. This is a gas, it will escape. This PbO in your book wrongly written. PbO is when it is hot it is reddish brown. Rb means reddish brown here. And yellow when hot, cold. When it is cold it is yellow. So here they are saying yellow when hot and cold. No, it's not like this. Reddish brown when hot and yellow when cold. And again divided into 2 parts. In one part add dilute nitric acid and immediately it will dissolve forming lead nitrate. Always take nitric acid, don't take HCl and sulfuric acid. If you take HCl then lead chloride is formed with HCl, with sulfuric acid lead sulfate is formed, and these 2, lead chloride and lead sulfate, they are insoluble. They stick on the piece of lead oxide and therefore stop the further reaction. Right, so we are always, in case of lead oxide we always take nitric acid, not HCl and so on. So one question can be set from here. Add some NaOH in another part of PbO, lead oxide, okay, then what happens, on shaking it will dissolve. That means it react with base also. If PbO react with base, that means it behave like acid, so form salt and water. Right, so with this we come to end of this chapter. Thank you, Vada.